Okay, welcome back. In this video, we're going to continue with our Year 10 reading a car investigation. Reminding what we've done so far, we've actually gone and read the assignment, we've plotted the data, we've done linear graph of the data. So you should have something at this stage that looks something like this. Now, I've gone and turned my data off, so I'm just looking at the graphs at this point. What I'd like to teach you today is how to find these points of intersection. It's very easy to do that on Desmos. You can just click on the point. So there we go. So these two options cost the same amount, about 700 at approximately day 5.5. Now on your assignment, you can't have day 0.5.56. It's either going to be day 5.5 or day 6. So one of these options will be better on day 6, and one of these options will be better on day 5.5. All right. So you can actually go and find all these intersections and click on all of them, and you can find, oh, well, this option is better before this day or more expensive after this day or whatever it happens to be. So, but how do you do that in algebraic form? Because if you look at the assignment, when the assignment back up, okay, we have Teams, and there's my notebook. So if you want to get something more detailed for B and A grade, you need to have algebraic solutions to questions 6 to 9. So these questions here. So when's the best option? Show that that's true algebraic. Use the graph or algebra to explain. So you can. I suggest you use both. The graph will justify your answer. And in particular, let's have a quick look at the graph for question 6. Effectively, there's only two options, and it depends on your day. So if you've picked 5 days, so the cheapest option is this blue option, 5, 6, and then on day 7, these are actually the black and the blue options are equal in value. All right, yeah, but if you have 8 days, it's now the black option, and 9 days is also the black option. So, but you can demonstrate that by just substituting values in. So, for example, this is the equation for that line, for example, is y. The blue line is y equals 100x. And you say, okay, and you can substitute the value in, and you can say, okay, so y equals cost equals 100 times x times 5. If it's 5 days, it will be $500. Although that's kind of trivial because you already have all this on your data table. You can say, okay, well, as we can see for on day 5, you can just go back to your data table and say, well, here's the cost, and this one's the cheapest. Okay, so that's kind of trivial. What isn't trivial is being able to find points of intersection by hand. Okay, so with algebra. And all right, let's have a look. So Lawn Sips are dirt cheap. Shanghai, same as Wicked Rentals. I might just pick, I'm going to pick a random one. I'm not going to give away the questions. You do need to put the work in and then check with your teacher, myself, if you've done this correctly. All right. Okay. So when it comes to, all right, let's just have a look. Okay. All right. Then back to this one. I'm going to have a look at, okay, I've got my red and my green lines. These are two linear lines, and we have an intersection at $500, and that's for 3 days and a third. 3 days and a third is not a reasonable answer, but we're going to prove that this is actually a intersection point using algebra. Here's my little method of how to do this. So when you have your two equations, equate the two right hand sides, isolate x and solve, substitute x in, so what you solve, the x that you find, into the equation and solve for y. Of course, I need to show you this with examples, so that's what I'm going to do now. Okay, so we have y. First one is y equals, my red line is the 60x plus 300. There we go. All right, so there's my my first option. The other option is y equals. That one was 90x plus 200. Okay, so there's my two equations anyway. All right. Now, what do I do? Well, I equate the two right-hand sides. So, okay, I might just type this out for the sake of brevity, so not just writing forever. So I'll just make my font size a little bit larger. Okay, so 200. All right, so I have 60 x, italics x, italics plus 300. Oopsies, it's not liking this. I don't know why it's doing that. Okay, there we go. Pardon me, I pressed the wrong key. All right, there we go. Plus 200. Oh, whoops, 300 equals 90x plus 200. Okay, so that's the first step. Oopsies. All right, now, so what we're going to do, and I'll write out the steps for each one as we go. So, all right, I want to isolate x. So I'm going to move all the numbers to one side and all the all the x terms to the other side. And I'm going to do this. I probably should swap the direction of these, but I'm not going to right now. All right, basically, my what I'm going to do here is I'm going to minus. Oopsies. Okay. New box. All right. The trick I'm going to do is I'm going to minus 90x to both sides. Let's just say minus 90. No, I'm going to do 60x. And I'm going to, so that's going to move, that's going to get rid of 60x on the left-hand side. I'm also going to minus 200. Okay. Right. So, okay, so there's my notes. All right, so what's that going to do? On the next line, all right, so 60 minus 90 is 0x. Now, you can write it all out if you want to, so I will for this instance, but you're going to get kind of bored of me doing this forever. All right, I'll even color code it for you. Minus 60x plus 300. But I'm also going to minus maroon minus 200. All right, and that's going to equal 90x. And I might just copy that over. I made it a bit larger. Still got plus 200. Oopsies. 200, and then finally minus 200. All right, so what does that do? On the next line, you have 0x, 300 minus 200 is 100. 100 equals 30x. Okay. Now, it's fine if you just write the second line, but just to demonstrate what's happened there. So whatever I do with simultaneous equations, I need to be consistent. All right, so I've equated the two sides. Whatever I do to one side, I must do to the other. So we got this. All right. Now, I'm going to, first thing I'm going to do is actually swap the sides. Let's also go and divide by 10 and swap the sides. So I'm going to, I'm not going to write that out. So I'm just going to go 3 x equals 10. Okay, then, all right. Then your final answer, all right, well, if you have 3x equals 10, if I divide both of those by 3, x is equal to, all right, x equals 10 divided by 3. All right, or 3.33 recurring. All right, so there's my x. All right, now the way to solve the next part is you need to take that value and substitute into here. Now, this happens to be a fraction of decimal, so it's not the most pretty way to do it. All right, and then I might just put this, I'm going to put myself a little boundary as far as that goes. Okay, now we're going to do next part is we're going to solve for y. All right, we're going to do substitution. Now, it doesn't matter what equation you substitute to, and you should get the same answer. We can check it on a calculator in a moment. All right, substitute x into either equation. You can do both, check. All right, let's make that a bit larger. Okay. All right, so try not to use the rounded value. So we have to do a little bit of fractions here. I'm sorry. All right, so we're solving for y. So we're going y equals y, italics y equals 60 times 60 brackets. I'll just put it away. I don't have a time symbol. Okay, 60. Okay. Substitute thread. Sorry. Okay, 10 divided by 3. All right, plus 300. Let's bracket. There we go. And 300. There we go. All right. So that's a bit messy. I might even just write it. I'm going to write it up here. So I'm just going to bring up my drawing. All right. So it's y equals 60 times 10 thirds plus 300. Now, there's a few ways you can do this, but you have to use expansion or BODMAS. Effectively, okay, 60 times by 10 is 60 over 1 if you want to think of it that way. So you can times these as fractions. So y equals 600 divided by 3 plus 300. And that is equal to 600 divided by 3 is 200 plus 300 is 500. Okay, let's prove it on my calculator. We'll do it both ways. Okay, so let me get my TI again. I've closed that again, so give it a moment to warm up. Go on, Mr. Smart View. Talk amongst yourselves. Okay, here we go. All right, so if I do it this way, I'll just do it the way I was going to substitute into 600 times by 10 thirds divided by, 10 thirds plus 300. All right, and I get, whoopsies, nope, whoops, not 600, I'm getting ahead of myself. 60. I can't fix that. All right, we do that. Okay, no. Do it again. My mistake. All right, times 10 thirds plus 300. All right, that is now correct. 500. 500. Yep. So this is consistent with the answer we're getting, by the way. So yeah, 3 1/3 and 500. Now, just to prove I've got it right, let's go put that number into the other equation. The other equation is 90x plus 200. So 90 times 10 thirds plus 200. All right, see what happens. You also get 500. That makes sense. So these two graphs share the coordinate point of 10/3 at a y value of 500. That's the point of intersection. All right, so that's how you find the points of intersection. So you may have to do a few of these as far as when you're answering the questions, but this is what I'm expecting you to be able to do in terms of solving for points of equality or intersection when the cars cost the same for the same number of days. You need to be able to solve this using the graph and also using algebra like this. So I'm going to stop the recording here and I'm going to rest my voice.